Hello and welcome back. Alright, so up until this point in our course, we haven't really talked about solving any real world problems. We've just been talking about concepts and theory behind the concepts and a little bit of practicality on how we can implement those in code in C++. Well, today we're actually going to take a look at solving a real problem. And so with that, let's go ahead and jump into our whiteboard and figure out what our problem is that we're going to solve. Okay, so our problem. See, we want to store an arbitrary, that's an R, arbitrary number of items. Oops. Number of items. Okay. So if we think about all the data structures that we've learned so far, we know that the array is the only type of collection item that we've learned about. The array has a problem though. It is fixed size. It's hard to change the size. It's also contiguous. What that means is that in memory, an array needs a sequential number or contiguous side-by-side one whole block of memory for its array parts. And well, that's not so great for the problem of arbitrary number of items. So how else might we represent this? Well, we've actually already learned enough to solve this problem. And so if we think about the types that we've learned about, the one that seems the most appropriate is the pointer type. Because the pointer allows us to point to various places in memory. So if I draw this chain of multiple pointers going all over the place, we can see that this is actually starting to look like something that could solve our problem. Right? Because if we have a pointer that points to here, and this pointer points to here, and this one goes to here, well, we've started to chain together, or link together, different areas in memory, based on the memory address of this pointer. Well, we need to be able to store not only this chain of data, but we also need to store some value, because, these items represent something. So for our purposes, let's say that they represent an integer. Alright, so we have this pointer that goes through, and now we just learned about the struct, which allows us to group together items that we want into a related type. So how could we mix those together? So maybe we have two things in our struct. We have one, we have the value, let's call it, we'll just say it's an integer, and then we have the pointer that points off to the next group of this type. So we have another one, and let's go somewhere, and then we have another one. And let's say that this one just stops. Okay, so this is actually a basic data type, or a data structure that you learn when you take any computer class, either in high school or college. It's called the linked list. It allows us to solve this arbitrary number of items grouped together in some sort of related manner. So this has the benefit of being able to store basically small little segments in memory, and they don't have to be contiguous. Now, it doesn't have some of the performance characteristics of an array, because as we know from the pointer arithmetic video, that arrays are super fast to find any particular index of this array. Let's say you wanted this one. Well, we know we just add the offsets from where the array starts to here to get that. Well, in a linked list, we actually have to traverse each one. So let's say we wanted to find the second item, or the third item in the list. In the array, we just jump to this location because it is the array pointer, it's the address, plus 3. Right? But in a linked list, we have to go 0, 1, 2, and let's pretend there's another one over here. So this goes up to here, 3. So we have to traverse each one individually. But the trade-offs are we can add a new item super fast because we just go down to the last guy, change this null pointer like I just did here, change this null to to point to a valid block, and we're good to go. Okay, so what are we actually going to name this block? So I don't have to call this some generic terms. Let's call this a node. Okay, and so this node is made up of our integer value and a pointer, and we'll call it next. Now, what is this type of this pointer? Well, it's going to point to another one of these nodes. So it's just a node pointer. And if you look at what we have here, this is actually already looking like a struct definition. Okay, so let's go ahead and jump over into Xcode and actually start implementing this. So here I have just a plain empty C++ project. So let's go ahead and define that node struct that I was talking about. So we have struct node. We have int value. And we have node pointer next. Perfect. So if we want to define the first item of that node, we'll call it node, we'll call it list, and we'll do list.value equals 0 and list.next equals null. And null is a preprocessor definition. Basically, it evaluates to 0. Actually, it does evaluate to 0. The preprocessor comes and just replaces this value null with the value 0. We use null just because it's semantically more clear on what it is. This is telling me that the next member in the node structure is pointing to no valid location in memory, and that's what the null is. Okay, so we can see that we've created our first list, or our first list node. So what this has literally done is we've created this. We have our two pieces. We set our first value to 0. This is list, and we have set our pointer to null. Okay, so how do we actually add a next item to our list? Well, we need to create another node. So let's do node. We'll call this node n1. We will do n1.value equals 1, and we will do list. Well, actually, let's do n1.next equals null, and we will do list.next equals the address of n1. So let's see what we've done here. So now we've created another node. We've set this value to 1. We've set this to 0. This is n1. But now we have changed this list pointer. Right here, the next pointer in our list variable, to point to here. And so now what we can do is we can actually walk this list and print out the values. So let's go ahead and create a function that's going to do this for us. Okay. So up here, let's have a function. It's going to return nothing. And it's going to print the list. and it's going to take in a node pointer, and it'll be the list. All right, so let's see what this function is doing. With this function, print list, node star list. What this function is asking for is the address of the list that we want to, of the first node in the list that we want to start printing the output from. Now, in the previous video, I just had us pass in a plain old node. And while that works, and it would work in this case as well, it is inefficient. And the reason it's inefficient is because of the way functions get their data passed into them. In C++, all functions are passed by value, or all parameters are passed by value in a function. So let me write that again. Sorry, I guess I didn't need to erase it. Node list. So in this case, what we're doing is we are passing in the address value, which is an 8-byte figure. It's either a 4 or an 8-byte figure. On my system, it's 8 bytes. On yours, it may be 4 bytes, just depending on the size of your pointers in your system. Well, the size of this, of your node, is the composite of the two types that's in here. So the integer is a 4-byte value, and your pointer is either 4 or 8 bytes. So that means the size of your node is either 8 or 12 bytes. Alright, so when your function gets passed in a value, this item right here gets all of its bits copied from wherever it's getting called from. So let's jump over to Xcode here. If I were to call this function print list, and it's going to take a pointer, so I pass in the list. Alright, so this is the address of the list. So what I'm literally doing is there's the address. We have the address over here. We'll call it A. I'm sending this into the function, and we are making a copy of A. Now, if I were doing this top one, if I was doing a node list, I would actually be passing in this first node. And what I would do is I would actually get a copy of the node. And what that would do is it would copy all of this data. So I would get this copied and this copied. And so what I end up doing is I end up copying more data than I need to if I do a node list. And while this structure isn't that large, you won't see a huge difference. If I were doing that a lot, or if this node had 12 other items, that would be a lot of memory that would be consuming. So that was just a little side note on why I'm using the pointer here instead. And that's because of that functions are all passed by value. And so if we do the star, we can pass the address in of that value instead of the actual value itself. Sorry. So I hope that made sense. That was a quick little side note on pass by value and how functions actually get their data called into them. All right, so back to our print function. We have print list. So what we want to do is we actually want to start doing a little bit of error checking as well. Someone might pass in 0 into our list, and that would be bad, because we know if we try to dereference a null value, our program will crash. So let's go ahead and do a check for that. So if our list equals null, then we're going to go ahead and return. And notice that there's no return value that I'm passing in. I'm just using the keyword return. And the reason I'm doing that is that the return type of this function is void. So there's no data to return. There's no data type that I can return. Basically, it just tells the compiler to stop executing the rest of this function. Okay, so now that we are guaranteed that we're not having a null pointer, we can't really validate that the memory that we're being pointed to is correct, so that's just something we're going to have to assume is right. All right, so now we're going to want to create a loop of some sort. And this is what we're going to want to do. Let's jump over to our whiteboard. What we want to do is we want to print this value, which is 0 in this case, and then we want to go to the next guy and print 1. Okay, so let's go ahead and create a node pointer, and we'll call it next. And it will be initialized to list. And then we will continue, while next does not equal null. All right, and then we will set next equal to next. And now remember that node pointer, or that list, is a node pointer. So we don't need to dereference it here to assign it to this, because node or next is also a node pointer. Since next is a node pointer, we need to dereference it to get to the next field inside our structure. So we can use the arrow, or we can do the parentheses and dereference it. I'm going to use the arrow because I think it's cleaner. Okay. So now we want to output our list value. And the value is going to be equal to next value. And we are going to print a comma. And when we are done with our list, we will print a new line. All right, so let's go ahead and run this and see if it works. We see we got 0 and we got 1 and our comma. Perfect. And you notice that we didn't have to delete anything, even though we're working with pointers, because we didn't actually dynamically create any memory. So that's all fine and dandy. And this actually is our basic implementation of a linked list. In the next video, we'll go ahead and talk about how we start creating some functions to work with the linked list to make this task down here a lot more transparent to the user. All right, thanks.